Hello folks. Okay, well, last time around we took a look at functional programming in general, and this time I want to start getting into some actual programming in Lisp. So we're using Common Lisp, and our interpreter is GCL on our systems. If you want to have a bit of a look at a ton of sample code, I've put some together in the 330 site. Actually, if you go to the main 330 page, where are we here? There's a link for Lisp code and examples. And so I've tried to break it down with descriptions of a ton of different Lisp features, and each of them includes a variety of different examples. So it's all written pretty much as Lisp code. Tons of different examples, a bunch of more complex programming examples down at the bottom. So if you want to have some digging and some experimentation, feel free to play away in there and try this stuff out. So, ton of code available. Again, we're going to use GCL, and so that's located in /users/bin/GCL. Ultimately, we'll take a look at writing scripts in Lisp as well as writing code that, or using code directly in the interpreter. So when we're doing that, the first line of the script will be the usual idea, tell it where to find the interpreter, so the #bang /user/bin/GCL. The one thing to remember is you'll need a -f on the end, so just an option to the interpreter telling it that we're running stuff from this file. Now, last time around we talked about pure versus hybrid functional languages. This is very much a hybrid language. We're going to try to sort of generally lean towards functionally pure solutions, but really there's a lot of times when it just makes more sense to use the hybrid approach and to incorporate some procedural aspects. So that is what we will be doing as we plow our way along here. So for today, I just want to give you an introduction to a lot of the different common features and basics of Lisp. All right, where shall we start off here? So again, the idea is we're pretty much everything that we're working with is a function. If you want to define a variable, again, this is a hybrid language, so you can actually define and set variables. But the way you actually define a variable is through a function call. The way you define a function is through a function call for a special function that defines functions. The way you do everything is pretty much a function call, and every one of them is going to return a value. So if I run the function call defvar, so this is the function that defines a variable, I give it a variable name and I give it a value, this creates this more or less global variable x and initializes it to value 10. Comments, before I forget about it later on, are single line, and they go from a semicolon to the end of the line. All right, so again, typical single line style, it's just they begin with a semicolon. So one of the things to get used to in terms of playing with Lisp is that the syntax for a function call is to have inside the brackets the name of the function and then the values that it's operating on, its parameters. So, in a C style you would say square root, and then in brackets you'd pass the parameter. In Lisp style, the name of the function always goes in as the first thing inside the brackets. So that's going to take a little bit of getting used to. We all, especially when you're switching back and forth between other languages and Lisp, we all tend to forget once in a while and put the brackets on the inside instead of the outside, and Lisp is going to yell at us for us. Again, functions will always return a value. The default value is nil, and nil actually doubles as the empty list and also as false for that matter, but we'll come back and address that in a little bit. All right, so we'll start off by playing with the interpreter. If we just go through and I'll fire up the GCL interpreter and just play with running some functions. And again, for each of them, it will evaluate the function call and return a value. So it gives us a prompt, that greater than symbol, for instance, waits for us to type in a function call, it evaluates it, and then displays whatever the function returns. So let me see if we can play with this a little bit. So let's say I run GCL, and it gives a little blurb when it fires up. Eventually it gives you this prompt waiting for you to type in commands. Now I can type in literal values, so I can type in something like 25, and of course the value of 25 is just 25. But I can type in function calls, so if I do something like, okay, well tell me what the square root of 25 is, it'll evaluate it and come back with a result. If I want to add 5 and 10 together, again, remember we've got this syntax where the operator is always going inside the brackets. I can nest function calls. And it looks to me like my recording is not capturing the whole window here. So I'm going to actually quit out of this for a second. Let's see. So let's say I go through and I want to nest function calls. I do something like I want to add the result of subtracting, I don't know, 5 from 10. So here I'm doing, right, 10 minus 5. And again, subtraction is our function call in that case. The addition is our function call. So I want to add the result of subtracting 5 from 10 to, I don't know, let's multiply 16 by 30 or some such thing. So it takes a little bit of getting used to in terms of the layout for this. Again, just because the brackets are always going on the outside. But this is going to go off and perform whatever it is I desired. All right. Quit is the function that gets us out of the interpreter. All right, let's go back and plow on a little bit here. So again, we can run quit to get out. There is a few things to get used to when you're playing with this. If you do wind up with a crash, it'll go through and give you, actually I should show that. This makes more sense if you've seen it. So if I run GCL and I do something like foo, so I give it something that's just garbage, it gives me this error message. They're not always terribly intuitive, but it gives me an error message. In this case, it's telling me that it's trying to regard foo as a variable, but it hasn't seen the definition of a variable named foo, so we've got this basically undeclared variable. And it tells me that it's broken, and then it gives me a bunch of numeric options. Right now it's only giving me one option. It can be the case that if you get sort of deeper into Lisp cycle, you can wind up with a sequence of options here for different points you can return to. Generally what you're going to want to do is to get back to normal operation. So look for whichever number says return to the top level and enter that. So in this case it's just 1. And it gets me back to my regular prompt, which you can't see. But we'll continue on with our cycle here. Let me see, what else did I want to go through? So you can go through, and if we've got a file that's got a bunch of Lisp code in it, we can load that in the interpreter. Or if we've got another file that's got Lisp code in it, it can load the code from, one file can load code from another one. And it's just this function call, load, and the name of the file whose code you want to read. So this is somewhat like a hash include in a language like C. So again, the idea is basically just go off, grab and run the code that's in that other, run the definitions for the code that's in that other file. So we can start mixing and matching files, which is something that we'll wind up doing in Lab 1. Let's see. Again, we took a look at the idea of functions and parameters. Everything, all the things we usually think of in terms of operators are essentially treated like functions as far as these calls go, where we're saying inside the brackets, the first thing is the operation we want to carry out. So if I want to add 10 and 25, it's plus 10, 25. Right? If I want to subtract 2 from 6, it's minus 6, 2. So it does take a little getting used to, but you will get the hang of it. There's a read function that reads a value from the user. So for instance, if I wanted to read two values from the user and add them together, I could do a plus with two calls to read. So one of the nice things about read is that it does do a very good job of reading whatever the user enters and interpreting it correctly as a Lisp data type. So if the user types in 75.5, again, it's going to recognize that as a float. If they type in 112, it's going to recognize it as an integer. If they type in foo in double quotes, it's going to recognize it as the string foo. If they type in just foo without quotes, then it's going to treat that as a symbol, like an identifier, if you like. If they type in a list of values in brackets, it's going to recognize that as a Lisp list. A couple of other data types that are worth mentioning. T is true in Lisp and nil is false. If you're trying to represent individual characters, like the sort of single quoted characters in something like C, it's the hash, backslash, and whatever character it is you want to represent. So there are a variety of different data types that we'll play with, and again, read will pick up on all of them. So if I wanted to do something like, let's read in two values from the user and add them together. Now, I don't have any prompts in this, so there's no output. It's just immediately going to wait for me to type in the first value, and then it's going to wait for me to type in the second value, and then it's going to do the addition on the results. So I type in my first value, I type in my second value, and it comes back with a result. So read is a useful beastie. So again, you can play with this stuff as much as you like, work with this stuff in the interpreter, and we'll start playing with putting the code in files and doing that. So actually, we'll take, once we show how to print output, we'll go through and create a couple of files and play with that. Lots of the common math operators, plus, minus, divide, multiplication, a bunch of built-in functions, min and max, where you can give it a whole list of values and it'll give you the smallest or the largest. Mod for integer division, the remainder after integer division, logs, square roots, all the usuals are provided as built-in functions. If you want to raise one thing to the power of another, right, it's exponent, so expt, and the thing you want to raise and the power you want to raise it to. Pretty typical set of comparison operators. Let's see, equality checking is something we'll come back and talk about a little bit later, simply because the two things you're comparing could potentially be of different data types. So we will come back and treat the equality comparisons as a special issue a little bit later on. Oh. I thought I was doing this later. Okay, we'll do equality checking now. How about we do equality checking now? So there's a bunch of different equality checking operators. So there's equal, and you give it two things, or equal P, or EQL, or EQ. So EQ is the most restrictive. It's just checking to see if X and Y are actually referring to the exact same item. So if you think of it in terms of, say, pointers in C or C++, we'd be testing to make sure that X and Y are actually both pointing at the exact same item. EQL is a little bit more flexible. It's going to return true if they both refer to the exact same item, or if one of them is a variable and the other one's a literal value, and the literal value matches the value in the variable. So it's a little bit more flexible. Equal P is checking to see if they're equivalent values. So it'll do type conversions where it can to see if these things match. So it would treat 3 and 3.0 as the same thing. Right? It would return true. Is 3 equal to 3.0? It's equal P is going to go through and say yes, whereas the others might say no. And then equal, the most general of these beasties, is going to go through and do structural comparisons. So you can use this with things like lists to see if the contents of the two lists are actually the same all the way through. So you've got a variety of different equality checking operations available, and we'll play with these as we get deeper into this. Now, of course, there's a whole slew of different operations available for specific data types. So strings are provided in double quotes typically. A whole slew of different operations. You can use length to return the number of characters in the string. ELT is actually the one for, so this is essentially for element. If you want to get the ith character in a string, ELT, the string that you're looking at, and then which position. There's concatenate, that you can use to take two strings and return the concatenation of the two of them. So in this case, you call concatenate, tell it that what you want back is a string, and give it the two things that you want concatenated together, and it doesn't actually change either of those strings, but it gives you back a string that's the combination of the two. There's a variety of different comparison operations again. You can see, you can do string comparisons. So it's string less than is the name of the function, and give it the two strings. And it, again, more or less alphabetically goes through and says, is S1 alphabetically less than S2, more or less. Again, this is using the kind of ASCII approach to things. Characters, again, the hash, backslash, and whichever character it is the literal form. And there's a slew of different built-in character operations. So char uppercase to return the uppercase equivalent, downcase for the lowercase equivalent. You can convert back and forth between a character and its ASCII code with char code or code char. You can do comparisons to see if one character is pseudo-alphabetically less than the other. Again, it's basically just using the ASCII values, but a whole slew of different built-in character functions. A bunch of special characters out there, the hash backslash backspace or space or return or tab for obviously backspace, tab, return, whatnot. Symbols are a bit of an interesting beastie. So we don't usually think of being able to look at a variable name as, if you like, a value in a programming language, but in Lisp we can. So symbols are essentially identifiers. So just X by itself, well, actually, let's take a look here. Let's fire up GCL, and if I do a def var x10 or something like this, so I can go through and create a variable. If I ask if x is a symbol, it's going to say no. If I ask what the value of x is, it's going to say 10. So by default, Lisp is going to try and evaluate the parameters it's given and go through and say, oh, okay, well, when you're referring to x, you want me to evaluate x and use its value in the call to symbol p. So this is basically going off and passing a 10 to symbol p and asking if 10 is a symbol. And it's going to say, no, 10 is an integer, it's not a symbol. So what we will often want to do is instead go through and say, okay, please don't evaluate this symbol, just tell me if the thing itself is a symbol. So this is asking if x is actually a symbol. Don't evaluate it, just tell me if x is a symbol. And it's going to tell me true. So we can start treating the symbols themselves, the foos and x's and whatever else we're working with, as values and looking at properties of them. One of the things we can do is see if a particular symbol has a value associated with it or not. So the function for doing that is called boundp. So I can ask if x has a value bound to it, associated with it, and it's going to say no. If I check, oh, sorry, I'm exiting and entering here just because I've got only part of my screen showing up on the recording. However, if I do my def var again, so let's set x to 10, and then check if x is bound to a value? It says yes, because I have associated the value 10 with x, right? I've declared it as a variable. So we can, as a program runs, we can look at a variable name and ask the question, has this variable been declared? So all sorts of interesting possibilities crop up as we're playing with this stuff. However, we will come back and play with that much later. Again, we've mentioned the use of def_var to create a variable and initialize a value. You can also set the value of an existing variable using setf. So setf, the name of the variable, and the new value that you want it to have. Now, it doesn't have to be the same data type as it had before. So variables are dynamically typed in Lisp, meaning that no variable has a specific data type. You can stick any value in any variable at any time. And later on, we'll look at the implementation of Lisp that allows this to happen. But again, the idea is we can change data types anytime you want. Now, that does mean that before we use a variable, we have to check and make sure that the data type that's stored in it right now is actually of the type that we want. So we're going to have to introduce a bunch of type checking as we start playing with Lisp a little bit more. Now, again, we mentioned earlier that pure functional programming, you don't have variables. So obviously, this is one aspect of Lisp that makes it very much a hybrid. You can do the same sort of idea with constants. So def constant, and the name of your constant and the value for it sets a constant. There are a bunch of predefined constants that we'll come back and talk about later on. Things like most positive double float, and essentially things like the C-limit library, where you can go off and figure out what the maximum or minimum values or what the default values for things are. So we obviously want to be able to print things out in most programming languages. So format is the one that we'll introduce for now. Format allows us to print something to standard output. So it's format, and we'll throw in this parameter t for the moment, and remember t is just true. So format, true as the first parameter, the string that you want to print out, and it will display whatever it is you decided to show. The tilde% is somewhat like the \n, right? It's in Lisp, this is the character that, or in Lisp strings, this is the character that we're using to say, format, please print out a new line at this point. Now, format displays the content of the string to standard output, and then it returns nil, right? It's a function, it's got to return something, it returns nil. We can insert values into the midst of our format statements, just like you would with a printf in C, for instance. So the idea is we use some kind of a placeholder, so it's the tilde. So if I wanted to say something like the value of x is, and then have the value of x pop up in the string here, we throw in the tilde, and in this case I'm throwing in a new line afterwards. And then after the string, you throw in the value that you want displayed in that position. So this is going to come out, if x is, say, value 10, this is going to say the value of x is, and it's going to stick the 10 in that position and then a new line. And you can have as many of these things as you like, right? If you want to set something like x is tilde a, y is tilde a, then you'd throw in x and y as the two values to be inserted at the end of your format statement. So we can use output. You can give formatted output. There's a lot more to format that we'll get into a little bit later on. You can actually get format to return the string instead of printing it out, and you do that by, instead of giving it t as the first parameter, you give it nil as the first parameter. This is saying don't print it, instead return it. And so in this case, the format is going to return the string that you built instead of displaying the string that you built. So if we were to, let's say, now let's actually write a little script that we'll throw some Lisp code in now that we can do some reads and writes and whatnot. So I'm going to create an executable Lisp script that I can run from the command line. And so we'll start with that #bang /user/bin /gcl-f. And I'm going to stick in a format statement, please enter a number. I'm going to read it and, why not? Let's store it in a variable. So let's read it and store it in a variable. So again, def_var is declaring the variable x, and we're performing a read, and whatever read returns, the thing the user typed in, we're storing in x. And then we'll do a format statement. You entered, let me try spelling here. You entered ~a, so the value of x is going to go in there. And I give it the thing I want displayed. So here I've got my script to do a print, a read, and a print. We have to make this executable to be able to run it. And then I can run my script, and it asks me to enter a number, and it says you entered 25. And of course, I don't really have to enter a number. I could enter foo, and it's going to say you entered foo. I could enter list 1, 2, 3, and it's going to tell me I entered 1, 2, 3. So again, read can recognize pretty much anything that I wind up typing in. All right, as long as it's a valid Lisp data type. All right. Oh, hey. I knew I would intend to do that. Yeah, so you can go through and create executable scripts like we just did. You can go through and, again, have your script load code from other files. So maybe let's take a look at that. Let's see now. How about... Yeah, lost my mouse. Hang on. So this time, let's have a... let's give you a sneak peek at functions. So we'll create another Lisp file here in which I'm just going to stick a function definition. I'm going to create a function f that takes 2 parameters and prints them both out. We'll come back and talk about the mechanics of function definitions in the next time around, I think. We'll print out the 2 beasties. So you passed ~a and ~a, x and y. So I'm going to have this function that's got, or this file, mystuff.cl, that's got a function definition in it. What did I call my script? Example. So in this script, I'm going to load mystuff.cl, and I still can't type. So this time, let's say, please enter, how about 2 values? And we'll call that function f that we wrote in my stuff. So I'll call f, and I'll pass it the result of reading 2 values. See how that goes. Oops. Please enter 2 values, so let's say 10 and blah. You passed 10 and blah. So you can now write scripts. You can stick Lisp code in files and load that into other files. You've had a sneak peek at how to write functions in Lisp. And we've got a bit of an introduction to how to play with the language in general. All right, so we will do lots more with this over the next 5 or 6 weeks. I think I will leave this one there for now.